As we continue with factoring and solving quadratic equations, we're going to use the quadratic formula now. And we have done simple factoring. We've done the AC method. We've done the square root property. We've done the completing the square up until this point. But now we're going to talk about the quadratic formula. And the quadratic formula may not be the shortest method, but it will factor any quadratic equation. And just there's going to be some limitations, and when we use it, we'll be able to see at this level, we're only talking about real solutions. But continuing on with the quadratic formula, you have, this is going to be your quadratic formula, where x is going to be equal to negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. So that would be my solution, x equals. And then I'm going to plug this information in because hopefully you may have an idea that the a, b, and c values that you are going to use will be from the standard formula ax squared plus bx plus c equals 0. So those are going to be the values that you're going to take from your equation and put into the formula and solve using your order of operations. And then we will find too, and we will discuss it, that this portion right here, or more specifically what is in the radical, is called the discriminant. And that little thing, if we take that out of the formula, that will identify how many solutions you're going to have. And we will also go into those examples. But just so you know, that's what we're going to be working with, and we're going to be doing some simple substitution to get to that. So, using the quadratic formula, it says, what are the solutions of x squared minus 4x equals 21? And it says use the quadratic formula, or it reads use the quadratic formula. Now, what we know is we need to start with it in standard form. So I need to get it into standard form. So what I did is I subtract 21 from both sides, and now I have it in standard form. And I can find out that a, my coefficient here, is 1. My coefficient here, which is b, is going to be negative 4. And then my constant, or c value, is going to be negative 21. Now all I have to do is turn around and input that into my equation. So I have negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. And I've done some substitution. So where I had b, I've input negative 4. Where I had a, I've input 1. And then where I had c, I've input the value of negative 21. And now I just start working out the order of operations and my operations. So I have minus negative 4, so that becomes a positive 4. Inside my radical, I have negative 4 squared, which becomes 16. And I also have minus 4 times 1 times negative 21, which becomes 84. All of that over 2 times 1, which is 2. Simplifying, I get 4 plus or minus the square root of 100 over 2, which is going to be 4 plus or minus 10 over 2. And again, plus or minus, that means I have two answers. So that's going to be 4 plus 10 over 2, or 4 minus 10 over 2, and then that would simplify down to 14 over 2, or 7, and this simplifies down to negative 6 over 2, which is negative 3. That is using the quadratic formula. So we are going to simply do some substitution and simplify, which we've doing the substitution and evaluating problems since the second week of school. So I want to first, what are the solutions of this? And use the quadratic formula. In order to use the quadratic formula, I need to rewrite that into standard form. And I know that standard form, I have subtract 2x from both sides. And when I subtract 2x from both sides, I get x squared minus 2x minus 8 equals 0. And I know that a is going to be equal to 1. B is going to be equal to negative 2, and C is going to be equal to negative 8. And again, A, B, C. Now I'm going to substitute that into my equation. So I have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so when I do my substitution again, x is going to be equal to negative, and b is negative 2, plus or minus the square root. And I have negative 2 squared, because that is going to be b squared minus 4. And then a is going to be 1. And c is the value of negative 8. And all of that is going to be over 2 times 1. And again, simplifying that. Fight the urge right now. A lot of students want to put all of that into the calculator like one big giant equation, and usually they get it wrong because they put one character incorrectly. So fight that urge. So I have simplifying 2 plus or minus the square root of 4 plus 32 over 2, which is going to be 2 plus or minus the square root of 36 over 2. And now I know that I have x equals 2 plus 6 over 2, or x equals 2 minus 6 over 2. And that plus or minus came from the square root of 36 is 6. So I just simplified that. Now when I simplify that more, that becomes, this is 8 over 2, which is going to be x equals 4. Or this becomes negative 4 over 2, and x equals negative 2. Those are my two possible answers. So there you go. Those are my possible solutions using the quadratic formula. Now, again, using the quadratic formula may not be the easiest method, but it will surely get you there. It will be a solution. So looking at finding the approximate solution. So if a batter strikes a ball, a batter strikes the ball. The equation is y equals negative 0.005x squared at plus 0.7x plus 3.5. And that models the path where x is the horizontal distance in feet. Okay, so x is the feet that the ball travels, and y is the height. Okay. And how far from the batter will the ball land round to the nearest tenth of a foot? Okay, well, I know that this equation is a quadratic equation, so I have negative 0.05x squared plus 0.7x plus 3.5 equals 0. And if I use the quadratic formula, because I can't factor that, goodness knows I can't factor that. A, B, and C. A is going to be negative 0.005. B is going to be 0.7. And C is going to be 3.5. And I can just do some substitution. I have negative B plus or minus the square root of b squared. Yes, you will probably get tired of writing the formula out, because I'll have you do that with every problem for the first couple of lessons to make sure that you know the formula. And simplifying, I have negative b, and we said b is going to be 0.7 plus or minus the square root of 0.7 squared minus 4 times a. Okay, negative 0.05 times C, which is 3.5. All of that is going to be over 2 times negative 0.005. And let's see here. Let me make sure I got that right. Negative b is going to be 0.7 plus or minus the square root of 0.7 squared, b squared, minus 4 times a times c, all over 2a. Looks right. So do some substitution here, or do some simplifying, sorry. I have negative 0.7 plus or minus the square root of 0.7 49 minus, I'm going to get a calculator out for that. Okay, so it's not going to be minus here, it's going to be plus, because I do have a negative times a negative, so that should be plus 0.7, plus 0.07, sorry. And all of that is going to be over 2 times negative 0.005, which is going to be negative 0.01. And then, so now I can do some simplifying here, and I'm going to have negative 0.7 plus or minus the square root of 0.56, all of that over a negative 0.01. And let me see, I'm going to figure out what that darn root is going to be to the decimal, because it's asking us to the decimal. So minus 0.57 plus or minus the square root of 0.56 is going to be 0.748. I'm just going to round that up to 0.75. All of that over a negative 0.01. So I have x is going to be equal to negative 0.7 plus 0.75 over negative 0.01, or negative 0.7 minus 0.75 over negative 0.01. And when I simplify these both down to their own solutions, I get x equals. Okay, so my answers came to x equals negative 5 or x equals 145. Well, negative wouldn't make sense to have distance in there, so x is going to be approximately 145 feet would have been the final answer. So that's how far we were from the ball, how far from the batter will the ball land, approximately 145 feet. This is the quadratic formula, using the quadratic formula in different manners, and how the discriminant can help you determine the number of solutions. Okay, so choosing the appropriate method. Which methods would you choose to solve each equation and justify your answer? Okay, well, looking at these, I've done two, because we've done many methods of factoring now. And if I look at A, I can factor the factors of 12 that will combine to give me negative 8. I can find that that is negative 6 and negative 2. So I can factor that one fairly easy. This one also, if I simply, in D, if I have 3x squared minus 9, I don't need to factor that because I only have the one variable, which is x squared. So I can just use my square root property. And then if I use that as an example, well, in B, I also can use the square root property and just solve. Also, that would apply here because I only have one level. I can easily add 32 to both sides. And then I have 2x squared equals 32, easily solved to continue on. So those would be square root properties. Let me see, any other square root properties? I don't see any others that I can use a square root property on very easily. But let's see, I could use the quadratic formula probably on any of these, but if I look at H, are there any factors of negative 15 that will give me 4? There aren't, so I am unable to factor this using factoring by grouping or any other easy factor. Therefore, I would want to go ahead and use my quadratic formula here. I could use my quadratic formula to go ahead and factor that one because I have an A, a B, and a C that I could use. Let's see, what else could I do? The quadratic formula. I'd probably use a quadratic formula here on C too, because when I go to factor by grouping, if I multiply A and C, which is 5 times negative 1, I'm not going to come up with factors that equal 13. So I definitely wouldn't want to factor that one. If I look at F, here, well, I can actually come up with factors of 10 that will add up to give me 7. So I can go ahead and factor that one pretty darn easy. So I would just go ahead and factor that one. Let me see what else. The other two, G and I, will take a second, but I'm running out of time, so I'm going to move forward here. And we're going to talk about how many real solutions. I take that back. Let's go ahead and do those. Okay, if I look at those G and I real quick, it looks like G is easily factorable, so I could factor that one, but I would probably go ahead and use a quadratic formula because I'm unable to find any factors of 6 times or 6 times negative 17 that sum to be that 13. So those are some things to consider. Now, as we talk about the discriminant, this discriminant is what is located inside my inside the quadratic formula. Negative b plus or minus square root of b squared minus 4ac. All of that is going to be over 2a. Now the discriminant is going to be that stuff that's inside the radical, which is right here, and it's going to drive and create or determine the number of solutions a quadratic equation can have. And the one way to think about that is, well, if I take the square root of a positive number, I'm going to have two possible solutions, a positive and a negative solution. If I take the square root of 0, well, there is only one solution to 0, and that is 0. And then if I try to take the square root of a negative number, there are no real number solutions. And that's going to help us determine the amount of, solutions to each quadratic equation. So if I'm going to use this, and we'll set this table up real quick. Okay, so as I go and I use the discriminant to use the quadratic formula to fill out the discriminant, in the first equation here, my first example where I have b squared minus 4ac is greater than 0. Okay, greater than 0, so that means we're looking at a positive number. So when I do my substitution, I have negative 5 squared minus 4 times a times c, and that is going to give me 193. So that is a positive number. So I know that I'm going to have two real solutions. And when I look at that as a graph, I have y, x. That is going to be a function that looks like this. I'm going to have two real solutions, which means I have two x-intercepts. And that's what it means when I have a solution. Remember, my solutions, my roots, my zeros, my x-intercepts are all the same thing. When I go and do the discriminant on the next one, I have negative 6 squared minus 4 times a times c, which is going to give me 0, 36 minus 36. Well, when I put that on a graph, it's going to look something like this, where I'm going to have it's going to touch just at one point right there. And that is going to give me one solution, and because it touches the x-axis at one point. And then finally my next example is when b squared minus 4ac is less than 0. Well, I have negative 3 squared minus 4 times a times c, and that is going to be equal to negative 31. So when I see that graphed, there is no solution. I can't find the square root of a negative 31, so we have 0 solutions, and that graph is going to be up here. It's going to be up it's not going to cross over the x-axis anywhere. So as you can see, two solutions mean it crosses over the x-axis twice. One solution means it touches it one time, and no solutions means that it never crosses over the x-axis. There are solutions, just no real number solutions. And that's how you use the discriminant to determine the number of solutions that you should be looking for. And that